Do you know the habits exhibited by the productive software engineering teams? Hi, my name is Umer, and I have been in the software industry for about 15 years. During this time, I have delivered tens of projects, lead a dozen teams, and I have written about 200,000 lines of code. I have seen a lot of ups and downs in the deliveries of software projects. And what I have noticed is that almost all the teams that are very productive in the long run and almost always deliver successful projects always exhibit certain habits and patterns. And today in this video, I'm going to share some of these examples with you that you can also implement in your project to improve the productivity of your team. A productive team always focus in three key areas. Effortless understanding. It's about making your software artifact and the overall process so effortless and as simple as possible, so that we avoid any human errors and any mistakes that happen because of the unnecessary complexity and extra cognitive load. It also helps during the time of stress to avoid unnecessary mistakes, and it really helps onboard new developers as well. The second key area is efficient tooling. The tools are there to help you, and it should make your workflow faster rather than creating hurdles for you. A good and productive team master their tools and make sure that they delegate as much work as possible to the tools and automation and focus on the real stuff. The third and most important part as a team is the effective collaboration. No team can survive if they are not collaborating and working in silos. Covering all three areas is beyond the scope of this video, but I will give a couple of examples from each areas to give you an idea on how you can tackle the hurdles in these three areas to make your team much productive and successful. So let's start with the first one, effortless understanding. Okay, take the example of this code. Can you understand what's going on in the first glance? So our first key area, our first example about reducing the cognitive load is to keep your methods short and the name descriptive. So let's see in this code, let's try to understand. So we have this some functions are called process orders, so we can understand that it's about processing some orders. And if we come here, we have a couple of problems here. We don't know what is this O1 because it's a very short name. I need to go trace it back here and see, okay, it's our order. Similarly, I here is we have absolutely no idea unless I go back and trace that this is our item or not inventory item. So you can see that it's yes, you can read it because it's relatively a simple example for the purpose of this slide. It is still contained within one screen, but it will still give you a tough time to understand this and increase your chances of making mistake. Now let's see how we can improve this. So here we have the exact same function, process order, but what we did is that we implemented a single responsibility pattern. So here we have the exact same function, process order, but what we did is we implemented the single responsibility principle. So now we created some private methods to encapsulate the logic, and we don't even need to read the code to understand what's happening. So first one glance and we can see that what this function is doing is what this method is doing is to process the order. First it validates the payment, then it moves to the second step of updating inventory, and then it sent the confirmation. Okay, and then of course this logic will be described here in these functions. Now let's take the second example. It's about minimizing coupling. It's also related to the keeping your methods short and implementing a single responsibility principle. Once again, this is not covering clean code principles is beyond the scope of this presentation. But I'm just giving some the key examples which are the low hanging fruit to reduce cognitive load. Here we can see that we have a class user manager, and we are trying to update a user. But what this class is doing is that it is trying to do some different things based on the role of user. And basically, it is making a decision based on parameters. So essentially, it's doing two things within one function. Let's see how we can improve this. So here, If you see, we have a user manager and we are updating a user. Internally, it's simply called user.update. So how it works is that we use the encapsulation and we define different kind of users, and each user will have its own update method. So we do not need to worry what kind of user is this. There's no decision is made. There's no if else conditions to track, and the user will be updated as per its role by using the encapsulation. So this is how we minimize the coupling. We keep our code decoupled and simple to understand. Let's move to another example. This is my favorite ones. Reduce indentation. So here, what's going on? We need to process a shipment. We have an order. We need to process a shipment, and in order to process this shipment, we are going to check if the order is not null, very typical check in Java. Then we are ensuring that the order is paid, and we also need to check that if order is not shipped. Okay, but by the time we are coming here, we are very nested in this if conditions. So imagine that here at this place, we let me see. At this place, we are now writing something that. Let's say we need to say if it is not paid, we need to send a reminder to user. So we will be having here, no, it will be here, yeah. So here we will be sending a reminder. Oh, I am writing by mouse. You get it, reminder. I skipped the. Okay. So, but you see that if you are seeing a reminder here, or if you see a error here, okay, for E, and if you see a sum log here, and you need to really track it back, like why what we are doing here and what was the condition that failed. Okay, so it really make it difficult to track, and then you need to keep, especially if we have this else clause here, to we need to keep this track in our mind that which step we are in and how nested we are going. Now, so let's see how we can improve this. This is definitely not a good idea to do. Yes, this is called. So how we can improve is something called a guard clauses, and what it does, it promotes early return. So it's the same function doing exactly same thing, but we reverse the conditions. And here, when we get an order, we simply check if the order is null. If it's null, simply exit. If order is not paid, exit. And if order is shipped, exit. And now if we want to do something like display error, we will simply have a bracket here, right? And we will be doing the error. So we exactly know that this condition failed. And as a result, we did error. If we want to send a reminder, we will be doing it in this condition. And if it was already shipped and we just want to write a log, we will be doing it here. Okay, and once we are here after this return, if none of these conditions is triggered, which means now we need to process the order. So it makes it understanding very simple. Again, this matter is breaking the SRP principle a little, but the example here I wanted to give was the guard clauses, and it works perfectly fine for this one. So do all your checks in the beginning and exit from the matter. And once you are done all your checkings, then just perform the core logic in as flat manner as possible. Now that's the right way, and now let's move to another example. Okay, this one is pretty basic. It's about comparison. It's a very standard statement, a standard way of comparing variable in Java and many other languages. We want to compare the value of a variable str. We first check if it's null, and then we compare it with whatever we want to check, right? And then we do something. It looks good, but what happens here is we often find ourselves in a fatigue that should we check for null here? Didn't we already check in the beginning or someplace? And sometimes we simply forget to check for null. And at the end, we get a runtime exception that this variable was null. So how we can solve this? Here. So we simply switch our comparison and we bring the yes to the beginning. Now you don't need to check for null. You don't need to think if it was we did a null check before or not, and it do the exact same thing in a much simpler manner. Personally, what I do for null checks, if I ever have to, I usually do null checks in the public methods, and once I am in a private method, I assume that the because it's usually in the same class, I assume that the public method has done all the checking, so I don't keep doing the null checks and trim and all this kind of extra work in private matters, but this is my personal preference. Okay, so these were some examples of how you can do certain like conscious efforts to make your code really less complicated, to reduce the complexity of your code. So these were some examples of how you make your code simpler to understand and avoid human errors while someone is reading your code or modifying something. And now we will move to the second category of efficient tooling. I already have a video coming on what are the tools you can use to maximize your productivity as a software engineering team. So I will not go much deeper here. And again, I like I said that this is a very broad topic to tackle all multiple areas. But let's see. I will still give you some ideas on how your tools make your productivity much better. So first of all, a lot of engineers, when I talk to them, they say that we are engineers by principle and knowledge, and we do not depend on code. And that's true. I also never uh, check for your knowledge of tools during interviews. But the thing is, when you are working on a project and you work 6 8 hours a day with a certain tools for about next 8 months, 1 year kind of time. It's really a good investment to spend some time on these tools and learn how to use them efficiently. So, one, it saves a lot of time. Second, it uh, it reduces the break in your flow. So when you are in the flow, in the zone of writing some logic, you do not need to fiddle around the code and always keep breaking your natural flow of working towards some solution. So, some base highlights that every developer should know is, for example, if you are using version control, let's say Git, either you use or not, but you should have a pretty good idea of what is rebase versus merge and when to use one, and different techniques that are available to keep your Git history clean. Similarly, when you're using IDE, you should have these keywords in top of your mind about the code navigation, moving to different classes, matters, their usage, going back and forth in that code. Even if you don't like to use keyboard shortcuts, there are some mouse and pointing tools available that also help you go back and forth very fast. Like usually the Logitech MS series is not a sponsored message, but I like that mouse to go back and forth. But anyways, yeah. Similarly, when it comes to code editing, you should have the keyword like shortcuts like use of the multi-cursor, duplicating line, moving lines up and down, etc. And when it comes to refactoring, you should know how to do the rename, change of signature, extracting some code to another method, and of course, debugging. You instead of just using some print statements, you should be able to like step over, create memory profiles, etc. So these are the things that once you master it, it really saves your time to debug issues and work through the core areas much faster. Similarly, the other area of tooling, a major area is the CI/CD pipeline, and that really can be used at your advantage. You can use like static analyzers and different tools to enforce and improve your code quality. For example, you can use like Sonar Cube or Kudo Merge for some automatic reviews for basic stuff, or check style to check for formatting and other basic issues with the code. You can your pipeline can indicate the code coverage, which can be done by SonarQube as well, or you can use other tools for that. This once you make it automatic, it's really hard to miss, and developers can implement it by themselves rather than wait for wasting the precious time in your code review meetings to handle these kind of basic issues. So these were some examples of how you make the efficient use of tools in your software delivery. Now let's move to our third area of focus, and I think it's much it's the most important one when it comes to overall effectiveness of the team. Let's focus on the effective collaboration, and I believe the best part of effective collaboration of the team, that the most effective, second most effective method of software engineers to collaborate after bitching is code reviews. And you should really use the code reviews to the you should really make the best of these code reviews to and to do that, in an ideal scenario, once you enter into a code review, either the reviewer or reviewee should come out learning something. One, yes, there was absolutely no problem. Both were aligned. That's good. But if there was a disagreement, one party should learn, and it should not be a reminder. You should not be spending time reminding, hey, you did not write unit test, or the coverage was low, or can you check the formatting? Can you put the bracket in the next line? All these things can be handled by the tools. What you should be focusing in the code review is about business logic, is complicated bugs. It is a great way of sharing knowledge on how to achieve certain technical stuff. It is to share knowledge of the existing code base. So let's focus on the real stuff and avoid wasting these precious hours in some trivial things that can be handled by by different tools. And other collaboration area, if you think about it, is documentation, right? And this is one thing that developers hate. Nobody want to write documentation. And the second issue with this documentation is that even if somebody take the effort and write, they get obsolete very fast. And so one of the ways that I have found to make it really live and interesting for the developers is to make unit test your living documents. So let's see how you can do. Here we have this unit test that is testing a method called can process, and it is doing some stuff. It is creating a bunch of orders with some parameters, and depending on some parameter, it is asserting true and false. And I'm assuming that it is covering some test cases here, but it doesn't give out exactly what it's doing. It's definitely covering some test cases. Okay, so let's see what we can do. Okay, so here, this method is okay. So this method here, we have these three test cases, right? Let's see. We are going to move these to individual methods and write a better definition of it. So now the first case, if you read the name, it is making it very clear. We are testing the method can process. The order is below approval limit, so it returns true. Basically, if it's below the approval limit, it can go. So if we create an order with, I think let's just consider as an amount, 30, and if we create a processor, the processor will be able to process this order. Now see what was the next test case that was returning false. Now it makes it very clear. Method is can process and the order is above limit without approval. So it's gonna return false. Now we create an order and when we try to process, there was no approval assigned and it's gonna return false. Let's see the third example. Now here we have an order which is above limit, but now it is approved by manager. So at the end of the day, it's gonna return true. Makes sense, right? So what we did is we took this test case, which was doing its job, but it was not making anything clear, and we turned this into this. We divided into three unit tests, and all of them act as a documentation, which clearly define what this function is doing. And if there's any change in code, it will break the unit test and we will need to update it. So this way, this document within the unit test case will always be updated. And other idea when it comes to another thing when it comes to collaboration and working in a team is number one, you learn the rules. But number two, you should know better when to break them. Because the developing of software is all about making trade-offs. Sometimes you need to make a synchronous call versus async. You create a dependency during your microservices between your microservices by making a async synchronous API call. You sometime instead of doing the normalization, you denormalize and make the redundant data available at different tables or even different databases. Sometimes you create a superclass or a context wrapper or some hard-coded config. And all these might seem like breaking a rule, but if you know exactly what was the reason, it it is what it makes um, the difference between a stupid or naive mistake versus a good decision. So you can break the rules, but you must know what rule you are breaking, and you must know your reason of it. If you are new, you should simply learn the best practices and follow them. Don't try to break it. But as you are getting senior, as you are learning more, you should also know when to break it to achieve your desired result. Okay, the next part in the sustainable delivery, in the okay, the next part in the good and effective collaboration is about making the delivery sustainable. I have seen it time and again that the teams, because when they are new, they are like highly motivated, or they just form a team and everybody want to like prove something. Plus, each individual have some low hanging tasks. The velocity of delivery is much high. But what happens is that once the time passes and we enter into area where now we need to do the integration of different modules that is built, our velocity take a hit. It start dipping, and then we start to see more and more bugs because of some much faster delivery that happened in the beginning. It also set very wrong expectation for the managers and stakeholders. When they see the velocity, they expect the similar results across the whole timeline. But because of some initial mistakes, it doesn't happen, and some of the hacks and fast deliveries usually drop the whole delivery velocity. And as we move on, we accumulate a lot of tech debt and keep increasing the bugs. So in an ideal what you can do is that you should always plan in the beginning and always move at a sustainable pace. So what you should be doing is that you should always move at a sustainable pace and plan out for the complete for the big picture and all the integration points to avoid this kind of velocity dip and accumulating tech debt. And to do that, you should encourage the study and okay, so what you should be doing is you should always encourage the steady and sustainable pace. Plan out for the bigger picture and all the integration points. Do regular code reviews and ensure that you are constantly testing for the integration and to add results, and always promote healthy work life balance and healthy environment that encourage innovation and learning as well. From learning, this is actually my next point. So usually a productive team, they always share knowledge. They are ready to mentor their juniors. They keep themselves updated. Code pairing is also a very good exercise that usually these teams do, and they are always ready to experiment and innovate. In fact, they reserve some time to do all these activities. It also reflect on the culture that which allow them to do all these activities to make sure that they are staying updated. They are the knowledge is flowing correctly within that the knowledge is flowing flawlessly without any blockers in the team. And also they always contribute back to both the teams and society in general. And with this, we completed the three key areas that make the software team highly productive, and we discussed different examples.